So now let's have a look at this example, which is example number 3, and learn how to simplify this. So now I'm gonna rewrite the question. We have 3. Number 3. So we have 2 to the power of 3. We have a to the power of 3 over 4 multiplied by 4th root of a multiplied by 2 square root of b divided by 4b to the power of 1 over 2. We need to simplify this, right? So what matters is we need to know how to simplify this, applying laws of exponents. Now, I said to you, when you have situations like this, you start with the numbers and usually you see your numbers. But be careful how your numbers are presented. Now, let's have a look at these. We can see that we have 2 to the power of 3, we have 2 there, we have 4. And that means we have our bases as numeric. So where we have higher number or larger number, we're going to have to express those numbers, those numeric numbers and those numeric bases as prime numbers, right? As a prime number. In this case, already we have a prime number, we are safe, and the base is 2. Even there, we have a prime number, whereby the basis is also 2. So that means we have the same basis, so we can apply the laws of exponents, right? So now, at the bottom, we have 4, which is not a prime number because there are more than one factors. Sorry about that. We have more than one factors that we can use to actually represent 4. So right now, this is what we're going to do. We're going to express all of the numeric bases as prime numbers. So this one we can just write them as they are for now. So now we have 2 to the power of 3, and therefore there is nothing that we can do with this one. Multiply by 8 to the power of 3 over 2. And then what is the golden tip? We don't want this root, so that means we're going to have to express it as a as an exponent. So we have 4th root of a, so that means you're going to have a to the power of 1 over 4, which is 4th root of a, multiplied by 2 to the power of 1, and therefore we have square root of b. Let's express that in terms of what? In terms of exponent. So we have b to the power of 1 over 2, and therefore we divide by, so again, we have our exponent. So, I mean, we have our base in this case, which is numeric. We're going to have to change our base into a prime number. So that means we're going to have, we know that 4, automatically, you don't have to write 2 multiplied by 2. We know that 4, it is actually 2 to the power of 2. Then now it is all prime number, and then the bases now are the same of numeric exponent, of the numeric bases. The numeric bases are now the same. Multiply by what? Multiply by b to the power of 1 over 2. Now we can collect. Let's start with the numeric bases. The numeric bases, here we have 2 to the power of 3. And at the top, we are multiplying the same bases, which is 2 and 2. So that means we're going to have to add the exponent. So that means it's going to be 3 plus 1. But we still have the same base at the bottom below the division line. So that means we are subtracting because we are dividing. So we're going to have to subtract this exponent of the very same base. So here we're going to have minus 2. Now we are done with numeric bases. Now we move to a bases. Multiply by a. At the top we have 3 over 2. We are adding the same bases because we are multiplying the same bases. I mean, we are adding the exponents because we are multiplying the same bases. So the exponent there is 3 over 2. The exponent there is going to be 1 over 4. Now we are done with a's, right? Now we move to b's. Now at the top, we have b to the power of 1 over 2. Now we have b at the bottom below the division line. So that means we're going to have to subtract these exponents because we have the basis whereby we are dividing our bases. So here we're going to have negative 1 over 2. Now let us deal with our numbers. So 3 plus 1 is going to be 4. And then 4 subtract 2, it's going to be 2. So that means here we're going to have 2 to the power of 2 multiply by. Now, what is 3 over 2 plus 1 over 4? I'm going to multiply 3 by 2. So I'm going to get 6. And then I'm going to have 6 plus 1. It's going to be 7 over 4. So that means we're going to have a to the power of 7 over 4. Actually, 7 over 4. So make sure that you write your exponent clearly and legibly, okay? I'm a little bit struggling, obvious, with my writing on this thing. But what matters is you need to understand how to solve these questions. So let me try to rewrite that. So that means here we're going to have 7 over as our exponent. 7 over 4. sorry about that. And therefore this half subtract half, most definitely it's going to be 0. So we're going to have b to the power of 0. Now 2 to the power of 2 is going to be 4 multiplied by a to the power of 7 over 4. And therefore this will be our final answer, because we know that b to the power of 0 is going to be 1. So 1 multiplied by this, it's still going to be that. You can express your b to the power of 0 as 1 to show that you are multiplying by 1 over there. And therefore you can say 4a to the power of 7 over 4. This will be your final answer. Can you see how much we managed to break this thing down from this expression to this? We managed to break it down. Okay, so that's how we solve number B. Number 3. So now we move to number 4. So number 4, we have 3 multiplied by root of 2 multiply by 3 to the power of 3 over 4. That long division line, we have square root of 1 over 3 multiply by 2 to the power of negative 1 over 2 multiply by 4th root of 3 to the power of 9. Aha. Now we can see that in this case, which is example number 4, where we need to simplify this, we can see that our bases are numeric and our bases are prime numbers. We don't need to do anything with our bases. We just need to apply laws of exponent. That is all. And the definitions of laws of exponents where necessary. So the first thing is we need to change this root sign into exponential form. So I'm just going to write everything as it is, except where I'm going to change the root signs. So that means here we're going to have 3 times, we're going to have to change this root into exponential form. So we're going to have 2 to the power of 1 over 2, that's a square root, multiplied by 3 to the power of 3 over 4. A long division line. And for this one, you can do it in 2 ways. You can just apply definition of laws of exponents. You know that when you have a fraction like this, how to deal with that, but it's fine. We can just express it in this way. We can start by writing it in this way. Say we have 1 over 3 over there. And then our exponent from this root sign is going to be 1 over 2. And therefore multiply by, we have 2 to the power of negative 1 over 2. Again, we need to change our 4th root into exponential form. So that means here we're going to have 3 to the power of 9, which is this, multiplied by our 4th root, which is 1 over 4. Right? That was the first thing that we wanted to do. I'm not yet quick to collect the exponents, but you can if you want to. It's still fine. But in this case, this is what I want to do. I want to write everything as it is and multiply these things. So that means here I'm going to have 3 multiplied by 2 to the power of 1 over 2 multiplied by 3 to the power of 3 over 4. Therefore, I'm going to divide. So now here you can just distribute that over that. But I feel like I want to write this using one of the definitions of laws of exponents. So I know that when I have something like this, I can rewrite it like this, which is 3 to the power of negative 1, right? When I change 1 over 3 to this base, I'm going to have to take 3 at the top. It's going to change its sign because it's more or less like I'm dividing. So hence why it's -1. And therefore, I'll write my exponent over there, which is 1/2. And therefore, there we have multiply by 2 to the power of -1/2. And then we distribute our exponent inside. So that means you're going to have 3 to the power of 9/4. I see that I still have this one that is not distributed. Let's just further continue so that you don't get confused. You will do or you skip the steps when you move further, not now, because we are starting to learn this thing. We are starting to learn these things. So let us distribute our exponent inside. So we're going to have 3 to the power of -1/2. You know, we just multiply in there. Multiply by 2 to the power of 1/2. Multiply by 3 to the power of 9/4. Now let us collect. So I'm going to complete my steps over there. Now let us collect the exponents using the same basis. So we have 3 to the power of 1 over there, right? We have 3 to the power of 3/4. So at the bottom, at the top, we are multiplying. So we're going to have to add the exponents. Let's write down the common base, which is 3. So then we have 1 plus 3/4. Do we have 3? Yes, we have 3 at the bottom. So we need to subtract that. So now the first exponent of 3 at the bottom is -1/2. So we're going to have to subtract -1/2. We're also going to have to subtract 9/4. Going to have to subtract 9/4. Multiply by 2. At the top, we have only 1, 2, which is 1 to the power of, to the power of 1/2. And the bottom, we have that. We're going to have to subtract that again, which is -1/2. Now, continuing with our steps, let us deal with the numbers then. So here we have 3. So we can just add these two guys over there. So 1 plus 3/4, I'm going to have to multiply this one by 4. So 4 plus 3, most definitely it's going to give me 8. 8 is going to, sorry, 7 is going to give me 7. So that means I'm going to, so far, I'm going to have 7/4. And therefore multiply this negative inside, it's going to be +1/2. Subtract, oh, I didn't see that one, subtract 9, but it's fine, you can just rewrite it as it is, subtract 9. This is 1/2, right? Subtract 9. Multiply by 2 to the power of, so here we have 1/2, we distribute that inside, we're going to have +1/2. And therefore, 7 subtract 9. These are the same, because now I'm starting to talk about these two exponents. These two fractions from these exponents, because I can see I have the same denominator. So I just gonna subtract the numerators. So I'm gonna say 7 subtract 9. It's gonna give me -2. So what will be -2/4? It will be half. And therefore -half plus half, it's gonna be 0. So that means here we're gonna have 3 to the power of 0 multiply by, but you can just punch this in your calculator so that you don't get confused. So, and therefore there we're gonna have half plus half is gonna be 1, obvious. So we're gonna have 2 to the power of 1. Now, according to the definition of laws of exponents, we know that anything to the power of 0 is gonna be 1, and therefore 2 to the power of 1 is still gonna be 2. So 1 multiplied by 2, our final answer in this case is gonna be 2. So we just simplify this expression over there without using a calculator, but applying laws of the exponents.